Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear student, Assalamu alaikum. I am Dr. Muslim Khan, Assistant Professor, Department of Chemistry, Cust. Today, the topic of our discussion is types of chromatography. This is the second online lecture of course code CAM 455, Chromatographic and Electrophoretic Method of Analysis. So basically, there are different modes of classification of chromatography. The first one is on the basis of chromatographic bed shape. The chromatography have the bed shape of chromatography will either be two-dimensional, which will be having 10, which is again further classified into thin layer chromatography and paper chromatography, and three-dimensional chromatography is having a the bed shape is in the form of column. We have also discussed this in our previous lecture that this classification you can call it that how the chromatography plane is basically held. The how the chromatographic plane is held. Either it can be held in a planar form, that is called planar chromatography. Planar chromatography is actually called a two-dimensional chromatography. This is again further having a 10-layer chromatography and paper chromatography. And we have discussed these two chromatography in details, 10-layer chromatography and paper chromatography. And the next one is three-dimensional chromatography, is also known as a column chromatography. The column chromatography we will discuss in our today lecture as well as in our future lecture, that what is a column chromatography. The next mode of classification is on the basis of solute interaction to the stationary phase. As we know that chromatography is having basically two phases. One is a mobile phase and other one is stationary phase. So basically in chromatography, we are mixing or analyte means or solute with mobile phase. Then this mobile phase is passed through the stationary phase. Then inside this mobile phase, we are having a solute, means the mixture, which is having different analyte. This solute having a different types of interaction with this stationary phase. So on the basis of this interaction, chromatography is further divided into partition chromatography, adsorption chromatography, gel filtration chromatography, affinity chromatography, and ion exchange chromatography. The next important mode of classification of chromatography is on the basis of physical states of a matter. Means you have two phases in chromatography. One is the stationary phase and other one is mobile phase. So if your stationary phase is if your mobile phase is liquid, and your stationary phase is solid, then it is called liquid solid chromatography. It means that your mobile phase can either be liquid or gas. So if it is a liquid, then it is a liquid chromatography. If it is a gas, then it is a gas chromatography. So the similarly, mobile phase can't be solid. And so on the other hand, your stationary phase either can be liquid or solid. So stationary phase uh, can't be gas. So again, then if it is a solid, then it is liquid solid chromatography. If it is a liquid, then it is called liquid liquid chromatography. But this one we will discuss in detail in coming slides. So we are not discussing we are not discussing basically this the planar and thin-layer chromatography means paper. We have also already discussed in detail in the previous lecture. Based on the interaction between sample components, means those in the light component which we want to separate with stationary phase, chromatography is classified into partition chromatography, adsorption chromatography, gel filtration, affinity, and ion exchange. We will discuss these chromatography one by one in detail. First of all, what is partition chromatography? Basically, this form of chromatography is based on a thin film formed on the surface of a solid support by liquid stationary phase. So the principle of in this chromatography, the separation of the component from the sample mixture is carried out by the process that the component partition themselves between the two phases basically. So solute equilibrates between the mobile phase and the stationary phase. So if this is your stationary phase, let's say if this is your stationary phase, so in this chromatography separation method where analyte where you have analyte is contained within a liquid or gaseous mobile phase is pumped through this stationary phase. So these different component in your mobile phase having a different interaction to this stationary phase as well as with your mobile phase. It means that the component in the mobile phase and with this surface they actually partition themselves between the two phases. So actually this usually one phase is hydrophilic and the other phase is lipophilic. Lipophilic. The component of the analyte interact differently with these two phases, with this hydrophilic and lipophilic phases. So depending on the polarity, they spend more or less time interacting with the stationary phase, are thus retarded to a greater or lesser extent on these two phases. So this leads to the separation of the different component present on the sample. So paper chromatography, as I mentioned it in our previous in my previous lecture, that usually students think that paper is basically a stationary phase. Paper is not a stationary phase. Inside the paper there are water particles. That is basically a stationary phase. So paper chromatography is one of the typical example of liquid chromatography is the typical example of partition chromatography. So we have discussed it in detail. I don't want to discuss it here, but this was just just a short introduction of partition chromatography. The next one is adsorption chromatography. Adsorption chromatography, we have also already discussed this in detail. This is one of the oldest type of chromatography around, this adsorption chromatography. It's in adsorption chromatography, it utilizes the mobile liquid or gaseous phase that is adsorbed on the surface of a stationary solid phase. So basically, the equilibration between the mobile and stationary phase accounts for the separation of different solutes. But this exercises the adsorption behavior of the stationary phase. The stationary phase used in adsorption chromatography is known as adsorbent. So this is basically based on the principle that some solid substances, which are known as adsorbent, have the power to hold molecule at their surface because, as I mentioned, adsorption is a surface phenomenon. It's not like absorption. It is absorption, and this is a surface phenomena. So a different adsorbent have a power to hold molecule at their surface. And this holding is why this holding is occurring. This holding is due to the weak non-ionic attractive forces of the van der Waal and hydrogen bonding, which only occurs at specific adsorption sites or beds. These adsorbent beds can differentiate between the organic molecule adsorbate based on their strength of a binding. So some molecule have a more strength, more interaction with this surface, this van der Waal forces, hydrogen bonding of some of the molecules are greater in nature and some of the molecule are lesser in nature. So these differences in the strength of the compound leads to the separation on the adsorbent surface basically. A solvent eluent mobile phase is constantly pumped through the adsorbent stationary phase in the column. Differences in the compound flow rate eventually leads to the separation of the organic mixture. The most commonly used adsorbents are silica, alumina, and carbon. And we have discussed also this in detail as well because thin layer chromatography is one of the typical example of adsorption chromatography. So our next one is molecular exclusion chromatography. This is also called gel permeations or gel filtration chromatography, but it is not like the adsorption or partition chromatography because this chromatography scientists have exercised not the interaction between your analyte and your stationary phase or mobile phase, but scientists have exercised the size of your analyte because your different analytes have different size. So this type of chromatography lacks in attraction between the stationary and solutes. But on the other hand, the liquid or gaseous phase passes through a porous gel, which is having pores, which separate the molecule according to its size, basically. The pores are normally small and exclude the larger solute molecule but allows smaller molecule to enter the gel, causing them to flow through the larger volume basically. So in this technique, the separation of component is based on the difference in the molecular weight or size. So different pores. So these are large molecule, these are the small molecule. The stationary phase used is a in this stationary phase is a polymer matrix whose pores are completely filled with solvent to be used as the mobile phase. The molecule and the sample are pumped through this specialized columns containing such microporous packing material, usually known as gel. That's why it's called gel permeation or gel. It is usually a kind of filtration, so that's why it's called a gel filtration chromatography. The basis of this separation is that molecule above certain size are totally excluded from the pores, while smaller molecule access the interior of the pores partly or wholly. The flow of the mobile phase, basically, the flow of the mobile phase hence will cause larger molecule to pass through the column unhindered without penetrating the gel matrix, whereas smaller molecule will be retarded according to their penetration of the gel. Uh, the component in this molecular exclusion chromatography are size gel filtrations. One is stationary phase, other one is mobile phase, and other one is the column which is having this gel, which is having this polymeric gel, and the pump which pumps mobile phase through the stationary phase, and the last one, the detector, which detect uh, the analyte component. Stationary phase is composed of semi-permeable. This stationary phase composed of semi-permeable porous polymer gel beds with a well-defined range of rock of pore size. It is the following. This porous gel stationary phase having this must be chemically inert. Should not react with your analyte molecule. They should be mechanically stable. So with heating or with some other things, it should not change its behavior. With ideal and homogeneous porous structure, um, means uh, having a wide pore size, giving low resolution. A uniform particle and pore size is one of the key to this gel permeation chromatography. Example of gel maybe uh, Cephadix, Dextron, agarose gels. These are some of the typical gel used in this gel permeation chromatography. Uh, Different columns are used: analytical column, preparative column, usual column, means narrow bore column. These are the different columns. Uh, this depends on the size of the beds. Like some of the column are 7 to 8 millimeter, some of the 25, 30, even 50, 60 centimeter long, and some are 2 to 3 millimeter diameter. And these are, and also pumps and detectors, different detectors are used in this chromatography. So this is one of the molecular exclusion, one of the type of chromatography. Uh, uh, so And the next one is affinity chromatography. In affinity chromatography, this is one of the most selective type of chromatography applied. Uh, in this chromatography, it utilizes basically the specific interaction between one kind of solute molecule and second molecule that is M-mobilized on a stationary phase. For example, the M-mobilized molecule may be an antibody to some specific protein. When solute containing mixture of protein are passed through by this molecule, because only the specific protein is reacted to this antibody, binding it to the stationary phase. This protein is later extracted by changing the ionic strength of the pH. It means that, as the name indicate, affinity. So basically, the stationary phase consists of this stationary phase consists of support medium on which the substrate is bound uh, covalently in such a way that reactive groups these are the reactive groups. This is these are the analyte molecule. This reactive group basically uh, consist of support medium and which substrate is bound equivalently in such a way that reactive groups that are essentials for binding of the target molecules are exposed. As the crude mixture of the substances is passed through the chromatography column, substances with a binding site for immobilized substrate bind to the stationary phase while all other substances is eluted. Even till the wide volume. Wide volumes is basically that volume in chromatogram. I will tell you what is wide volume. So once the other substances are eluted, it means that the bond target molecule can be eluted by methods such as like including competing ligand in a mobile phase, or changing the pH, or changing the ionic strength, or polarity condition. So you can easily separate those components. So in affinity chromatography, matrix is one of the is one of the component used in the and spacer arm and ligand. So we are not going into detail of what different components have uh, in affinity chromatography, but and the next one is ion exchange chromatography. And this type of chromatography, basically, the use of resin, the stationary solid phase in your lower classes, you know that what is resin. The use of resin is the stationary solid phase is used to covalently attach anion or cation into it. It means that the resin you are using, the surface of the resin will either be anionic or cationic. If it is anionic, so it means that if your analyte is cationic in your mobile phase, it will attach to the anionic side, and vice versa. Solute ion of the opposite charges, as I mentioned, in the mobile liquid phase are attracted to the resin by electrostatic force. So, means in this type of chromatography, electrostatic force is basically responsible for the attraction of interaction between the stationary phase and your analyte molecule, basically. So, in this chromatography, uh, as I mentioned it here, now we'll discuss on this stationary phase. So in this chromatography, the mixture of component onto individual component based on the relative interaction of these either cation or anion to this surface, which is either anionic or cationic. So ion exchange chromatography is a process that allowed the separation of ions and polar molecule based to their affinity, based to their interaction to the ionic exchanger. The ionic exchanger either can be cationic exchanger, either it will be an ionic exchanger. So it means that ion exchange chromatography is further classified into cationic exchange chromatography or anionic exchange chromatography. In this process, two of type of exchanger, as I mentioned, cationic or anionic, will be used in this chromatography. Cationic exchanger possess negatively charged group, and these all will attract only positively charged cation. These exchanger are also called acidic ion exchange material because their negative charges result from the ionization of acidic group. while on the other hand, an anionic exchanger have positively charged group that will attract negatively charged ion. These are also called basic ion exchange materials. An ion exchange chromatography is most often performed in the form of column chromatography. However, there are also thin layer chromatographic method that work basically based on the same principle of this ionic exchange and chromatography. So classification on the basis of we discussed this classification on basis of interaction. The third mode of classification is on the basis of physical state of the matter. If your mobile phase is liquid, that is liquid chromatography. If your mobile phase is gas, this is gas chromatography. And if the third one is supercritical fluid chromatography. We will discuss it. That what is supercritical fluid chromatography. So when your mobile phase is liquid, either your stationary phase is liquid, that would be called liquid-liquid chromatography. If your stationary phase is solid, then it is called liquid-solid chromatography. If your mobile phase is a gas, if and stationary phase is a liquid, this is called gas liquid chromatography, and another one is gas solid chromatography. So first of all, we are basically discussing this liquid chromatography. That what is liquid chromatography? Chromatography in which mobile phase is liquid is called liquid chromatography. So the liquid used is this in this mobile phase is called the eluent or mobile phase. The stationary phase usually is a solid or liquid, as I mentioned it before. In general, it is possible to analyze any substance that can be stably dissolved in mobile phase by this chromatography. So separation in this process, basically, this is if this is a column, and you have applied your your mixture with mobile phase. If this is going along with a column, here you can see, here you can't see it, but if this is going along with a column, with the passage of time, these different components are basically separating from each other. Even here, more visible, and then here, like here, this component, it means that this component is having less interaction with stationary phase. This is having is more with interaction with it. So it means that now this component is already eluted from the column, is gone. So is you have already detected there in the detector, but this is now eluting. So at the end, you basically get the chromatogram. So means that this is a chromatogram with this side is the concentration and this is the time. So it means that this one is eluted first. If this is 0 minute, 1 minute, or 2 minute, or three, four, it means that it's, let's say, in the sixth minute you have got it this component, and then the 8 or 9 minute you have got this. So this is known as a chromatogram. The concentration versus the time, that which time. This is now known as the retention time of this component. This is the retention component of this component. Here you can see the example of chromatogram. Suppose that this is the peak. So you can always, this is known as a baseline in chromatogram. This is retention time. If this is in minute, 0 minute, or 1 minute, two, three, so it is, this is the retention time of this, and TR. This is non-retention time. It in the baseline you will see here this small peak. This is actually known as a wide volume. Your column having something, so first will be eluted first that one, and then next your analyte. And then peak area, this is known as a peak area from here till here. So when you want to integrate peaks, you will either consider this. So you want to know the concentration of this component. Either you will integrate this, take the height of the peak. This is known as H is known as height of the peak. This is intensity of the detector signals, and this is the time. This baseline will always be greater than zero because this is known as noise of the machine. It can't be zero. Every machine must have some noise. This is the baseline. And how did this liquid chromatography change into high performance liquid chromatography? Uh, because in chromatography high degree of separation is needed. Refining of the packing material, the- when you are reducing the size of the packing material, basically you need to you must have you need to pump this mobile phase with a greater force, with a greater pressure. For that thing you need some pumps that actually, because it reduces the analysis time, it must need the eluent through by a pump. So it demands for special equipment that can withstand a high pressure. Uh, so ultimately, this leads to arrival of a high performance liquid chromatography. We will discuss high performance liquid chromatography as well as gas chromatography in detail in our future lecture. We change into high performance liquid chromatography. Actually, in chromatography, high degree of separation was needed. For that thing, refinement of a packing material was needed. So the packing material size was reduced up to 3 micrometer, depends, sometimes 3 micrometer, 5 micrometer, and 10 micrometer. Also, to reduce the analysis time and delivery of this eluent by a pump was needed. So high pressure pump, and also a demand of a special equipment that can withstand this high pressure was needed. That's why this liquid chromatography, because of these changes, this liquid chromatography was changed into high performance liquid chromatography, which is called HPLC. So HPLC is a form of liquid chromatography used to separate compounds that are dissolved in a solution. Means basically this HPLC is an example of liquid chromatography. So HPLC instrument consists of reservoir of mobile phase, and this mobile phase is pumped by a high pressure pump, and then an injector which can inject this sample, and this sample along with mobile phase is passing through a separation column, and the different components which are eluting from the column are detected by detectors. So compounds are separated on the column in which sample mixture is passed through this column. The different component in the mixture pass through the column at different rates due to difference in their partition behavior, due to the uh, due to the interaction of these different components with the different phases. The mobile phase must be degazed before the column to eliminate the formation of air bubble in the column, because that can affect the column efficiency then. This is the flow chart of HPLC system. So in HPLC system, basically there are different solvent reservoir. So sometime two, sometime four, three. So this is solvent one and solvent two. So this solvent is degazed here before mixing. When these solvents are mixed, this is pumped by a high pressure pump to the column, but most of the time, or even sometime, before the actual column, a pre-column is also there, which can stop all the unwanted things from the column, because column is an expensive thing in HPLC. Also, it can affect the efficiency of a HPLC system. So after the pre-column, the sample injection port, which is this sample is injected into the flow of this mobile phase, which then this mixture is passed through this column, analytical column, and then like here also this flow splitter, which can split the flow of the mobile phase as well as the sample. So sum of the mobile phase means a very small part, also where the sample A is passed through the column, and most of these uh, sample as well as this mobile phase is going into the waste, and then at last here these different components are detected by detectors, and then it give us a chromatogram in a computer.